Welcome to Math 8, Unit 1, Lesson 11, What is the Same? This is recorded in front of class, so I will try and repeat student answers as much as possible for those of you who are learning online at home. That way you can hear what they are saying. To get started, we have this exercise, find the right hands, and it reminds us that a person's hands are mirror images of each other, and we have this beautiful diagram labeling what a left hand would look like. Kind of looks like a left hand in a very square Minecraft style mitten. I want you to shade all of the right hands. Now, students who have been in class, they've already had the opportunity to work on this. I'm going to ask a few students, please raise your hand so that you can go up and shade one of the right hands that is on the diagram. Get us started, please, Rhett. Yep, go up to the board and just pick up one of those pens, shade one of those right hands. As you do that, please remember the pen has not been sanitized, so you'll want to sanitize as soon as you're back to your seat. Beautiful. And I need another volunteer who can show me another right hand. Thank you, Dan. And one final volunteer once Dan finishes. Thank you, Lainey. Okay, it's looking good. Make sure you guys sanitize when you get back to your seats, since the pens have not been cleaned. Beautiful. Who has another right hand? Anyone else shade anything else? No? Because is that all of the right hands? Okay, now let's turn the discussion to how did you know which ones were the right hands and which ones were not the right hands? Logan, get us started, please.
I took my left hand and took like all the hands and decided to, if it's something on the right side, I would put my hand over it.
Okay. Good. So what Logan said, I'll try and repeat his answer and summarize it the best I can. He took his own hand and figured out where the thumb was and kind of twisted it into position, and if it wouldn't twist into that position, he would have to flip his hand. Is that right, Logan? And then once you had to flip your hand, you knew that it was the right hand and not the left hand. Okay. Anyone else have a different strategy that they like to share? All basically the same? Okay. I would like to point out that our hands are mirror images of one another, just like it says up here. Our hands are mirror images, and you can see that here in this diagram. Our left hand and right hand, they are mirror images. Go ahead and hold them up, and you can see that. You can see that your hands are mirror images. Even if you wear a ring or a bracelet on one hand and not the other, the hands themselves are mirror images. You can see that by pressing them together and identifying where that line of reflection is, right? You can see that your hands are mirror images. They're backwards copies. And so when we were doing this exercise, we probably were able to identify which ones were the left hands and which ones were the right hands, understanding that they are the mirror copies. So my next question that I have for you is, are all of these ones that are shaded, the ones that you guys chose to color in, are they the same? I know that's kind of a vague question, but I want you to think about that. Are they the same? Talk to each other. What do you think? Would you say yes or no? My question is, are they the same? Quick discussion time with your groups first before we talk as a class. That gives our online learners some think time. In-person learners, you should be talking to each other. This is discussion time. Thank you. Okay, now let's turn it to a class discussion. Share your thoughts with the online learners. Do you think that all of those hands that we shaded black, are they the same? Nevaeh, what do you think? Yes, why? Yes, though. They're all right hands, so they're the same. Good. Kaden, you want to add to that?
I say yes, because if you rotate each one of those, it's all goes to the exact position.
Good. I love that. Yes, because you're tying it into what we learned previously before we took our assessment. Yes. Well, it's not even asking that question. We're going to say all shaded are the same. Nevaeh knows that they're all right hands, but Kaden recognizes that they are all rotations of one another, tying it into what we learned previously. Now here's your next question then. are all of the shaded hands that you identified as right hands, are they the same as all of the other hands that are unshaded that you identified as left hands? Discuss with your groups. Are they the same? Quick discussion. Okay, share with the online learners. What do you think? Are all of these right hands that are shaded the same as the unshaded hands that you identified as left hands? Rhett, what do you think? What did you say, sorry? Yes, why? Why yes? Okay, they're still the same shape, but you said that these ones were left hands and these ones were right hands. So how are they the same shape if they're different hands? Let's expand on that a little bit further. Jacob?
All you need to do to turn these right hands into left hands is to just reflect them across a certain line of reflection.
Yeah, exactly. So tying it again into what we learned previously, all left hands are reflections of the right hands, just like it tells us up here, hands are mirror images. So all left hands are reflections of right hands. So we can even say that the unshaded are still the same as the shaded. And this kind of introduces this concept of what we're talking about by the same. I'm going to keep asking that question. Are they the same? We want to really kind of have a concrete, solid understanding of what it means when we say, are they the same? And that leads into our next section here, our next set of problems, where we're asking, are they the same? It says, for each pair of shapes, decide whether or not they are the same. This is where your geometry toolkits might be helpful, meaning your tracing paper, your index card, if you have it. Inside of your baskets are protractors. The protractors may be helpful to you. So I want to have the in-person students, you guys are going to be working with your groups and your geometry toolkits to go through this. Online learners, you're going to be doing the same thing, but you're going to pause the video so you don't have a whole lot of dead silence as all these students work. So go ahead and pause that video now. All right, students have worked in their groups. They have responses. They've used their geometry toolkits, including index cards to measure side lengths, protractors to measure angles, tracing paper to trace those figures. Let's see what conclusions you have come to. A, are these the same? What do you think, Logan?
Yes, the one on the right is like rotated 180 degrees.
Good. What Logan said is yes, because the figure is just rotated 180 degrees. Again, tying it into what we know before, it's the same image. It was just rotated 180 degrees. So that's how we know it's the same. How did you know? Did you trace it? Did you measure things? Okay, so we used our tracing paper. We saw that it was the same. It was rotated 180 degrees. Good. B, are they the same? What do you think? Raise your hand if you say yes, they are the same. Raise your hand if you say no, they're not the same. All right, please explain why you're saying no, Lainey. What do you mean by they're two different shapes? Okay, one of them smushed. Okay, I'll accept that. So we know that no, they're not the same. Do you agree with her statement that they are not the same shape? Kaden?
So this one, the first one is not as slanted as the second.
Okay, not as slanted. And you guys are using terms that work in the real life, but you're not using mathematical terms. How can we really talk about these not being the same using some mathematical terms? What would you say, Callie? Yeah, I like that word a lot. That does tell us that they're smashed, or that one is more slanted because they have different angles. I do like that answer a lot. And Jacob?
I did they both have different angles and sides.
And I did not measure. Did you measure using your index card? Are they for sure different side lengths? Okay, different angles, different side lengths. Good. Now, I want to challenge the comment that was made earlier. Are they different shapes? What is the name of this shape? No, it's not a rhombus. We've talked about this. You can't call it a rhombus just because it's slanty. What is it called, Nevaeh? No, it's more specific than a quadrilateral. It's a very special kind of quadrilateral ret. There it is, parallelogram. I told you to get rhombus in your head for the right reasons, but I think you're still confused. This is a parallelogram. What is this shape? It is still not a rhombus. You're killing me, Smalls. Do all of these side lengths have the same length? Really?
No.
This looks like it has the same length as that? No. So is it a rhombus? No. What is it? Still a parallelogram. So that's why I really wanted to challenge what was said earlier. Are they different shapes? Honestly, no. They're both parallelograms. They're both four-sided figures with opposite sides parallel. So, are they the same shape? Yeah, they are. Are they exactly the same, though? No, for all of the reasons that you guys listed. So we do want to be careful with that. We can also see if we were to use our tracing paper, although they're both parallelograms, I would have to definitely smash that one down in order to make it work. And C, who says yes, these are the same? Okay, anyone saying no, they are not the same? All right, who would like to explain why you're saying yes? Dan? Yep, they're reflections. Good. Flip left, right. Now we can see that they are just reflections, right? So, again, tying that in, whether you know it or not, you're tying it into what you know before. That as long as I can say that it's a reflection or a rotation or even a translation, then yes, they are the same. And how did you do that? Did you use your tracing paper? Okay. And let's move on to D now. D, are they the same? Who says yes, they are the same? Who says no, they are not the same? Okay, Jude, why not? Is it different angles though? No, they all have the same angles. Looks like they're all right angles throughout that whole figure and all right angles here. So we can't compare the angles. Instead, I need to focus on the size. Yeah, the side lengths. No, different side lengths. Any other thoughts or comments on that one? I'm going to put different side lengths even though the angles are the same. And E, are they the same? Who says yes, they are the same? Who says no, they are not the same? Good, I didn't fool anybody. I fooled myself though. I said yes, they were the same, but you are all saying no, they're not the same. Please tell me why. Who have I not called on in a minute? Aiden. Yep, this part that juts out here is pretty close to being in the middle of the figure, and here it's pretty close to the bottom. So I'm glad that you identified that it's not the same, not because it's rotated. Rotations are okay. It's not the same because that little piece, I don't even know what to call it. The part that juts out is too low. Too low on the figure on the right-hand side. All right, and I want to pay attention to this part here. Even though it wasn't mentioned, I do want to focus on the fact that if we were to ask maybe a second grader, are these two shapes the same? What might they say?
They would say no.
You think so? I think they would say yes. What if I asked a second grader, are these two shapes the same? What would a second grader say?
I think they would say yes.
Yeah, because what is this shape? This, exactly. All they see is a circle. All they see is a circle. So are these two shapes the same? To a second grader, they'd probably say yes. And honestly, to you guys, before we started talking about geometry, you might have said yes too. Are these two shapes the same? If we ask a second grader, what's a second grader going to say? Probably yes. If I asked you a week ago, what would you guys say? Probably yes, right? But now we have this different concept of what it means to be the same, and so we need to make sure that we're really being careful about the same, and we're going to continue to talk about that and really have a good understanding. So again, younger grades might say, yes, these are the same, they're both circles. Yes, they're the same, they're both rectangles. Yes, they're the same, they're both parallelograms. But we need to have a better understanding of what it means to be the same. Let's switch gears a little bit. We're going to talk about area, perimeter, and congruent. So move on to the next section here. And what we're going to be doing, if we read through the first three sets of problems, it says, which of the rectangles has the same area as R but different perimeter? Which rectangles have the same perimeter but different area? Which have the same area and the same perimeter? So let's get started by finding the area and perimeter of each. I will help you and get you started. P for perimeter means that we're building a fence around the rectangle, so we would need to add up all of the sides. Okay? So the perimeter of the figure R, rectangle R, is 3 plus 3 plus 2 plus 2, or 10 units. And area, I hope I still don't have to remind 8th graders how to find area, but I will anyway, just so none of you are embarrassed. Area is how much grass I would need to plant inside. Area is length times width for a rectangle. 2 times 3 or 6 units squared, not just units. It would be square units, just like grass is put down in squared units and fences are built along a line. Okay, so what we're going to do is we're going to find the perimeter and the area for each one of these. I will give you guys some quiet think time to do that. So online learners, pause the video so that you can calculate the perimeter and area of each one. Pause the video now. All right, let's talk about the perimeter and area of each one of these figures. Rectangle A, you can see it right here. What is the perimeter of rectangle A? Who has that for me? Kaden? 10 units. Thank you. I love that you even said units instead of just saying the number 10. I'm just going to go and do perimeters for all of them, and then I'll come back around and do areas for all since I'm color coding. Rectangle B, what is the perimeter, please? Lots of hands here. Aiden? 14 units. Yes. Figure C, perimeter. Rectangle C, what is the perimeter here? Dan? 14 units. Moving down here to D, what is the perimeter? Jude? 10 units. Rectangle E, what is the perimeter? Only hand, oh, there we go, Jacob. 10 units. And final one, rectangle F, what is the perimeter, Kaden? 10 units. Now let's focus on the areas. Rectangle A, I have an area of, Jacob? 6 units squared, love it. Rectangle B, the area is, Jacob, again? Thank you. Can I have some more hands, please? These are all simple multiplication problems. I would like to see some more hands. Rectangle C, there we go. Laney, 6, there we go. 6 units squared. Rectangle D, Nevaeh, 4 units squared. Rectangle E, what is the area, please? Logan? 6 units squared. And finally, rectangle F, Aiden? 4 units squared. Great job on remembering those units. Now, we're ready to answer this question. Which of these rectangles have the same area as rectangle R, but a different perimeter? So same area, the area here was 6 units. Which other ones have 6 units, but a different perimeter? Which ones did you list? Good, Lainey. B and Nevaeh. B and C, very good. Both of them have the area of 6 units squared, but these two have 14 units for their perimeter, and rectangle R has 10 units. Next question, which ones have the same perimeter, but now have a different area? This is why I color-coded this to make it a little bit easier. We have a perimeter of 10 units. Which other ones have 10 units for their perimeter, but a different area? Aiden. F and Dan. D, is that what you said? Yes, they both have 10 units for their perimeter, and the area is something besides 6 units. And now to finish up, I need ones that have the same area and the same perimeter as rectangle R. Which ones would that be? Good, Nevaeh. E and Aiden. E and A have the same as R. Very good. So, what does this all mean? What do we take away from this? Well, let's answer question 4 to really have a good understanding. It says use materials from the geometry toolkit. Again, that would be your index card, your tracing paper, protractors, etc. And decide which triangle or which rectangles, are congruent, shade congruent rectangles with the same color. So congruent, that would be where that tracing paper comes in handy. Can we go from triangle R to triangle C through a translation? Can we go from triangle R to triangle B through a rotation? So start highlighting those ones that are congruent or that are the same. Take another 30 seconds with your groups. Make sure you understand how to do this and get this done. 30 seconds starts now. Online learners, you can also do this during these 30 seconds. Okay, and that's it for your time. Are there any rectangles that are the same or congruent to R? Which ones are the same or congruent to R? Jacob? A? Any others? Dan? Yes, A and E are congruent to R. So again, that's something interesting to notice, isn't it? E and A had the same area and the same perimeter. So is just having the same area enough to show that it's congruent or that it's the same? No, it isn't, because R and C have the same area, not congruent. What about even R and F? Same perimeter, but are those congruent? Nope, so having the same perimeter isn't enough. Let's look at the other ones that might be congruent. B. Do you see any others that might be congruent to B? Anything that should be colored the same color as B? Which one, Jacob? C. And that leaves us with D and F colored a different color. Does that work for you guys? They should be colored that same color because they are congruent to each other, right? So here's the big takeaway from this. Okay, what I need you to take away from this exercise is perimeter isn't enough to show that they're the same. Area isn't enough to show that they're the same. We want them to have the same area and the same perimeter. And that's one way that we can show that they might be congruent or that they might be the same. Now, this Are You Ready is a great exercise. However, for the sake of time, I am not going to do this one. However, I am going to leave it as a challenge. Those of you who are wanting a challenge, this is a great question, and I will give you a hint. I want you to use your geometry toolkits, use your tracing paper, your index cards. That will be very helpful to you. And now let's go through our summary. I'm highlighting the important pieces of information just like we always do during our summary. And it says, congruent is a new term for an idea that we have already been using. The idea, and I have actually introduced this in a previous lesson, the idea is the same. but we need to make sure that we're really precise on what we mean by the same. And so we've developed, or I guess we have this new concept of what it means to be congruent, which is a really precise way of saying that they're the same. Here is the official definition of congruence that I do expect you to know. And honestly, it's one that you guys already have an intuitive knowledge about. Gentlemen, we say that two figures are congruent if one can be lined up exactly with the other by a sequence of rigid transformations. That's that key thing here, if we can go from one to the other through rigid transformations. And again, you guys already noticed this, because earlier on you said, well, it's just a reflection of the other. It's just a rotation of the other. So that's how I know that they're the same, or we would now say they're congruent. And we can see this example below. It says triangle EFD is congruent to triangle ABC because they can be matched up. ABC can be reflected across AC to be this triangle, and then translated through this vector to be this triangle. Notice that all of the angles are the same. All of the side lengths are the same. And that is part of what makes it congruent, but really what makes it congruent is the fact that we can go through that sequence of rigid transformations, reflection and then translation. That's how I know that they're congruent or the same. Let's continue on. Here are some other facts. Excuse me, sorry about that. Here are some other facts about congruent figures. We don't actually need to check all the measurements to prove two figures are congruent. All you really have to do is find a sequence of rigid transformations. Just like you already mentioned, we weren't able to measure that spiral from this page right here. We weren't able to measure anything about it, but we knew that they were the same or congruent because we can just reflect it. So you don't have to measure everything, you just need to figure out what transformations are taking place. A figure that looks like a mirror image of another can be congruent to it. This means there must be a reflection in that sequence of transformations. Again, rigid transformation, reflection. So if it's a reflection, it is still the same. Just like your right hand and left hand are mirror images, they are congruent. And here's another interesting one. This is going to come up in your homework, so do make sure you are highlighting this. Since two congruent polygons have the same area and same perimeter, one way to show that two polygons are not congruent is to show they have a different perimeter and area. So congruent figures would have the same area and same perimeter. So if you wanted to show that they're not the same, show that they have a different perimeter or different area. Let's quickly finish up this cool down and then it will be time to get cleaned up. It says figure B is the image of figure A when reflected across line L. So are figure A and figure B congruent? Just quick think time here, no discussion, just think time. Are figure A and B congruent? What do you think? Raise your hand so I can know who wants to share their thoughts. Good, Logan? Yeah, I like what you said, though. You're on the right track. Yes, what we just highlighted in that last bit said, what? What do we highlight? When we do a rigid transformation. Is a reflection a rigid transformation? Yes, it is. So if all I'm doing is a rigid transformation, like a reflection, is it going to be congruent figures? Yes, it is. Because a reflection is a rigid transformation, so yes, the figures are congruent. That's it for the lesson. Your homework is the lesson 11 practice problems. I know the numbering on your practice problems might be a little bit odd, but those are, that is your homework. That's it for today. Have a good one, and we'll see you next time.